I'm Trev Lucas Spa Woo, and this is Mr. Canu's AP Environmental Science class. Today, ladies and gentlemen, we're going to be involved in working a physics lab, working on force tables. And with that, I got to set the camera up so you can see what it looks like, and then we are going to go from there. Okay, since there's absolutely no editing whatsoever on this, okay? With that, all right. The main point about this lab, we've been talking about force vectors in physics, and we've talked about the idea of X components and Y components. And you guys have been dealing with calculating net force and all that wonderful stuff. So what does that look like for us for this practical demonstration here? Well, in this lab, there's going to be some pieces that you're going to be working with. This is the force table. That's what it's called. And what I did, I marked off the angles, okay? I marked it off with 0/360, 90, 180, and 270, okay? These are our scales. And what they're going to do, when they get pulled on, okay, they're going to tell us how many newtons of force are coming that way, okay? Now, there is the piece that with this peg that allows us to be able to connect it to the hole in the table. Okay, so it's going to fit like this. Okay, now there's another thing that you need to notice. You may notice here that this can actually move a little bit. Okay, I guess this one is set for that, but all right. So like some of these, they can move, okay, depending what's needed. Because you do have a spring scale inside here, and that can get stretched over time, over use. But the bottom line is, before we go and use these, we want to make sure that these things are set to 0. Now you may notice that there's a loop here. We're not going to use that, but we are going to use these hooks. We've been working with problems involving the net force acting on, let's say, an elephant, or let's say a boat being pulled on a river. What we're going to do here, we're going to be working with these rings, and with these rings we have 3 hooks that are attached to it. So this is what we're going to be doing for our lab. Now, how do you use this? For now, let's just go ahead and choose 2 of these, and they're opposite of each other, okay? So what's going to happen is we're going to take one of these, we're going to find the 270-degree mark, and you notice that there's 4 holes in there, okay? Let's go ahead and let's try for the second hole here, and then I'm going to do the same thing with the other side. I'm going to find the 90-degree mark, and I'm going to set it in the second hole here. Okay. You may notice that this one has a hook on it and this one has a loop. All right, we'll roll with it. Okay. I don't have enough hooks for everything, so if we don't have any hooks like this, then what we can simply do, we can attach our hook thing to this here, and we can work with it. Now the idea is you're going to be setting the ring in the middle here, in the center. Okay. And what we're going to do is we're going to hook it up like this and like this. Now you may notice, well, wait a minute, they're not pulling on each other. You're right, because they haven't been pulled far enough apart that it's nice and tight. So how do we go and do this? Well, we're going to take this and we're going to move it up 1 notch, okay? And you take a look at the reading, you'll notice that they're both still 0. Okay, well, what about the other side? So we can do the same thing with the other side here. And now you notice that this is now stretched tight, and you'll notice that, hey, there's a little bit of pulling here. Let's just take a quick look here, and you notice on this one here you have a reading, and it's not quite 1 Newton. In this case, it's like 0.8 newtons. And in theory, the other one on the other side should be the same, and what do you know? It's the same on the other side. Wow, I bet you were shocked about that. Lols. Okay, let's go back. So it shouldn't be a big surprise for us that this is going to be the same, okay? Because it's stretched out both sides evenly. But what if we needed to stretch it out a little further? Well, let's take this one here and pull that a little bit more. And if you notice, I'll take the reading here, it's 1.8, and here it's about 1.9. So now it's not equal. One side is pulling a little bit more than the other. So that's one way to look at it when we're looking at two things here, separating 180 degrees from each other. But what if I wanted to go and change this? If I wanted to move this, let's say I wanted to move it to the 0 degree mark here. And you may notice I can't measure that. So that means we're going to need a third one. Dun dun dun! Okay, so we got our third one. Now where in the world do we place this? Well, you know what? I'm going to go and place it on the 180 degree mark here. And I want to make sure that my dial is reading at 0 newtons before I do anything else. You're going to take that and we're going to go here and we're going to hook it like this. And you guys may notice, hang on, when you guys do the rings, make sure that our rods here are separate, that they're not tangled up, okay? So here is an example of what we have here. We have it at 90 degrees to each other, and we've got these readings to make, okay? That's basically it for the lab, okay, with this. And with that, because you guys are going to work with 3, you're not working with 4. And what I'm going to have you guys do, I'm going to have you guys create some situations here, okay, on the table. And I'm going to have you guys calculate it. Calculate the X and Y part of each, okay? And then, ladies and gentlemen, that's going to be your prediction. Then you're going to actually try it. And I'll give you guys a few examples that you can try to do. And no, I'm not planning to do this ahead of time. But again, you can go ahead and shift just to show what can be done. And then again, you can see how this is being pulled down more, and this is pulled, and this is pulled. So you guys can see the effects of the force table with this. Okay, so that's the basic idea behind the lab. I'm Trev Lucas Spawu, and let's face it, you're not. This is the end of the Physics Force Table Lab introduction. Take care, and may the farce be with you.